Okay, so we're going to look at series parallel, or what we call combination circuits here. And so if you notice, I'm using three resistors. I can't remember if the trainer has two 10s and 125 or two 25s and 110, but if you want to practice some of this, you're welcome to use the trainer out there. Your values will change if they're not the same value resistors. But what I want you to understand is how opens and shorts affect in simple series, simple parallel, and then in a combination circuit like we see here. So the very first thing, we always solve our parallels first. I always tell students that parallels are like parentheses. They're one of the first things, if you remember math principles, you solve parentheses first. We got to solve this parallel circuit first. So we got a 25 in parallel with a 10, and that value is going to be 7.14. And if you remember, we did that um, um, earlier on the parallel circuit we were looking at earlier. So then all we have to do is take and add that 7.14 to the 10, and we've got our total resistance. So our total is going to be 17.14 if we do a little rounding there. And so to get current, we got to divide 12 volts by 17.14 ohms. So we'll do that. 12 divided by 17.14. We know it'll be in milliamps simply because it's less than an amp. So it's actually 0.7 amps or 700 milliamps. And we know we see full current leaving the source and coming back to the source. I'm going to hover over this and watch the current here. And we should be seeing about 700 milliamps. And yep, I saw 699. We'll watch it one more time. And yeah, so 699 for all intents and purposes is 700 milliamps. So let's start with shorts this time. I can't remember which one we started with. And with shorts, it's going to depend on whether we're shorting something in the series or whether we're shorting in the parallel. But with shorts, unless we have multiple shorts, we're just going to change the behavior of the circuit a little bit. So I'm going to come in and I'm going to add a short across our 10 ohm. And this 10 ohm is in series to the parallel branch. So we know this 10 ohm is actually seeing full current. And if you watch there, all of the current has to go through that, because when it leaves the source, that's the only path out. We can see the 699 as meter was looking, yep, 699. So then it gets here and current can split, and then it has to come back after here and come back to our source. So I'm going to short around the 10 ohm, and we can see current flowing through the 10 ohm. And all we're going to do by shorting across this one is simply make this back to a simple parallel circuit. So what's going to happen is our resistance was earlier 17.14. Now it's going to be just 7.14. So current's going to go up because resistance has gone down. And we're going to take 12 and divide it by 7.14. And that equals 1.68 amps. So let's see. We know we got full current here. Let's watch. 1.3456. Yep, I saw 1.678. We'll watch it one more time. 5, 6, yep, 7, 8. So there we go, 1.68 milliamps running through that. Because in essence, we took out this 10 ohm resistor is what we did. And so shorting this series just basically makes us go back to a simple parallel circuit. Now, if there were another series resistor over here, which there could be, we would still have a combination circuit. But in the case of this particular circuit, we only had this one series. And what we'd have to do is we'd have to figure this parallel branch, add it to that resistor and this resistor over here, if there were one. So, but in the case of this one, we're back to just a simple parallel circuit with no series resistor here. So I'm going to do away with this and put us back to where we were. And I'm going to come down here and I'm going to short across our 25 ohm. And hopefully you already know what is about to happen. because what is about to happen is we're going to bypass both of these resistors, because electrically that point, that point, that point, and this point are all the same, as is this point, this point, this point, and that point. So in essence, we are bypassing our resistor, and the reason you're seeing current flow here is it's choosing that path. It's going, yep, not going through that 25, got this nice clear pathway, and it sees this nice clear pathway back to the source here, so it's choosing not to go here. And when I say choosing, I'm literally just meaning obeying the law of physics. So we know we got 12 volts supplied. We now have just a 10 ohm resistor, and so we should have 1.2 amps of current flowing through here. And I saw it then. We'll let it do go one more time, and we'll see we're getting about 1.2 amps of current flowing. So that's shorts as far as resistances go, and in this circuit. And it wouldn't matter if we shorted across the 25 ohm or the 10 ohm. Again, electrically, those points are the same. If we short one, we short the other. So we'll talk about opens. So opens will have a little bit of a different happening here depending on where we open. So we got three places that we got several places we could potentially open. We're going to look at opening each of these resistors and what that would do. So if we open a resistor, we essentially cut it in half or just not put it there. So if we open this 10 ohm resistor and there's an open, that means we could have left it out. It could be broken in half, whatever the case may be. We no longer have a circuit. We no longer have a path that leaves our source going through anything and returning to our source. So this is easy. If we open that series pathway, and even if there were another series resistor over here, the pathway back to the source on this side still wouldn't exist. So we have essentially killed current in the circuit. There's no flow, and that open would cause zero current to take place here. So I'm going to put it back. Now, if we open one of these, we're going to be doing something kind of unique, and we'll talk about each one. I'm going to cut this guy. And if you look, we still have current flow, but what we've done is we have taken what was a combination circuit and made it just a simple series circuit. Because if we leave the pathway and go back to our source, there's only one way we can get there. I can't go through here and jump across here because there's nothing there for me to flow through. So essentially, we've taken what was a series parallel circuit and made it a simple series circuit. So in this case, we got a 10 in series with a 10, so that means it's 20 ohms. So 20 ohms divided into 12 volts would give us 0.6 amps, and we'll read that anywhere in this circuit. So we'll watch, we should be looking for 600 milliamps. There it is. And again, it doesn't matter. I can go here, and we're going to see that same 600 milliamps. So that was, as they say, easy. Well, the same thing happens here. Now we'll have some different values. We still have a simple series circuit, but now instead of two 10s in series, we have a 10 and a 25 in series. And so that's more resistance, which means less current. So we're going to divide 12 by 35. And that's going to give us 0.342 milliamps. So let's look and see if that's what we're seeing. Yep, 342 milliamps. I think I said 0.342 milliamps. That's 0.342 amps or 342 milliamps. So my apologies if I said that wrong. So again, if we open the one that's in series, we just stop current flow. There's no path. If we come over here and open this 10 ohm, then we have stopped the ability of the source to have a current path back to the source. If we open either of these, we turn it into a simple series circuit, and we just have to add them together and we still have a path. And that's the differences between shorts and opens in series, parallel, and combination. You just have to put your thinking cap on and think about that current leaves the source and is going back to the source. And there has to be a pathway, has to be a circuit, a circular pathway. And even if that pathway on paper is not a circle, it's still in essence a circuit. meaning it leaves the source and comes back to the source. Otherwise, we would have an open circuit. So there you go.